Yeah, so good noon, everyone, and welcome to the lab sessions of PPS subject. Now, this is the first lab session, and we are going for online mode because of limitations here. Well, it's okay. So let's discuss some of the things first, how we are going to continue in lab session, whether it is online or offline mode, doesn't matter. Okay. I'm going to give you some instructions for the entire semester lab sessions, your submission instructions, and then we'll continue with the topics. Fine. We have already gone through this syllabus in the first lecture session. We looked at the content part. Now, as you all know, that first unit is all about theory section. Practicals will start from the second unit, fundamentals of C, when we start looking at the C language. And if we scroll down and have a look at the practical list, then your first practical starts with the C program language itself, which we haven't started yet in the lecture session. So what I plan is initially for 1 or 2 lab, we will go for some kind of basic practicals to understand computer system. Now, if the physical labs are going on, then we do have some systems, opened CPU cabinets, so you can see inside what is motherboard, what is hard disk, what is processor, where it should be mounted and how, right? But as long as we are running in an online mode right now, so what we will do is I'm going to give you some YouTube links, and you have to look those videos. Those videos are nothing but explaining how everything works and where it should be. So if physical process is not possible, then we will see some YouTube videos and we'll understand how everything goes. So for 1 or 2 lab, we will be going through that process, and once we start C programming language in lecture session, simultaneously in lab session, we are going to start these programs. Okay, so that's how we will be approaching our practical sessions. Now, once you perform your programs, what you need to do is you need to write those programs in a page, or you write it in a book, you write it in a separate page, doesn't matter, it's your choice. If you want to create a book for all the programs, you can. So what you need to do is, first you perform your program in the editor, you compile it, you run it, you have a look at the output. If everything goes correctly, then what you will do is you are going to write that program code in your page, pen and paper, handwritten code I want, okay? So first you write your code. Once you are done with that, below that code you write your output also. So you run your file in a computer, and whatever output you get, you write that output along with that code inside your page. So that will be the physical handwritten code and output. Then you need to take a photo or convert it to PDF anyhow, and you need to upload that PDF file in a Google Classroom. So I will generate a Google Classroom, and I'm going to invite you all inside that classroom. Later, I'm going to create practical assignments in that classroom so that you can upload your written page photographs or PDF files. Preferably PDF file. So you scan your written pages, convert it to PDF and upload it in a Google Classroom. That will be your submission, okay? So you submit each and every assignment that I ask, and you will have full marks for your internal component, okay? Now you submit on time and perfect code, then you'll have full mark. If you are not uploading correct code, marks will be deducted. If you are not submitting it on time, marks will be deducted. So remember, follow all the deadlines described in the Google Classroom when I generate. And you just need to upload your programs, not text file directly. Remember, you need to write that code in a page, scan that page, generate PDF, and then you need to upload it. Now you might be thinking why sir is insisting this lengthy process. Now let me tell you, in GTU examinations, you need to write your code in the answer sheet. And at that time, you are not going to have your text file or .c file or code file directly. You should be writing that entire code manually, pen and paper. And we want to practice that thing from the first lab itself. How we can write our code in pen and paper without system. Okay? So we want to practice that thing, and that's why I insist that every one of you is going to perform your code, run it, take an output. Then you are going to write that code manually in a page, write that output manually in a page, and then you scan that page, convert to PDF, upload that thing in the Google Classroom. That's how we are going to have each and every submission for practical work. Okay? Any doubt here? Right now, I have just explained process. When I generate a Google Classroom, I will also display, I will also share that Google Classroom, and I will make you aware how to use Google Classroom. Okay? So any queries related to Google Classroom, how to use it, will be discussed. But right now, we have just discussed the process. So if you have any kind of query or question, you may ask. Anything that you want to ask right now? Fine. Thank you, Hers and Manav and all. Right. So make sure that you follow all the deadlines and make sure that you write your program, then scan it and upload it. Not after every lecture. I'll generate those deadline assignments in the Google Classroom, and those deadlines you need to follow. Most of the times what I'll do is I'll ask you to submit 5 programs at a time. Okay? A single PDF file which consists of 5 programs. Fine? So is that clear, Rom? Yeah, okay. Now Viraj, your sound is not available in laptop. Why? Well, other students can hear me clearly. So Viraj, just check your speaker volume. Is that the problem with other students also, or only the Viraj? Yeah, clearly audible, right? So Viraj, you should check your speaker volume or headphone volume. Okay. Well, so that's what the basic instructions from my side to be followed inside lab sessions. And as I already said in the first lecture, I'm going to perform all these programs initially. I'll perform these programs, I'll explain each and every line of code so that you can understand that thing easily. And later on, what I'll do is, initially I'll perform entire program. Then later on somewhere, I'll perform half of the code, and then half of the code I'll let you perform at your end. And later part of, let's say after mid-sem, at the end of the semester, the only thing I'm going to give you is I'm going to explain what this definition asks you to perform, and everything you are going to do at your end. Fine. So that's how we are going to perform all these lab sessions. Now, if we go and have a look at the first unit, which we have already started in lecture session today, we have looked at the basic diagram, basic block diagram of computer, and we discussed something about hardware and software and all those things, right? Now, what we are going to do today in this lab session is I'm going to give you some YouTube links here in the chat box. What you need to do is you need to have a look at that video, and then we are going to discuss openly. We are going to discuss what you have understood from that video. Fine. So the first link is all about how memory works. Okay. So I'm going to post that link in a chat box. Have a look at your chat box and go through that link video. Have a look at that video, and once everyone is done, we are going to discuss that video here. So go and have a look at that video part first. Okay. It is, just let me have a look at it. It is around 5-minute video. So have a look at that video and try to understand what it tries to convey. And then we will discuss. Fine. So hopefully that video is completed. So I want almost all of you to share your thinking, what you have learned from this video, what you have understood, and let's rectify ourselves whether we are getting correct thing or not. Yeah. So anyone wants to share their understanding right now? Well, as long as this is just a lab session, we have limited students. You can directly speak, or if not feasible at your end, then you can write in a chat box. Yeah, so Vishal says binary codes from 0 to 1, 0 to 1, or 0 and 1, okay? To be very specific, Vishal. We do not have floating numbers, so we can say either 0 or 1. That's what the binary is. Yeah, Viraj says all about memory and input and output. Yes, it actually explains a lot more than the memory only. It has a number of things covered here. Computer works with binary data, where we can store our data in a memory, what kind of a memory, how processor works, where processor gets its input, and so on. So any other student wants to share their view? In lab session, I'll more prefer to go for directly audio. Instead of typing and wasting our time, maybe તમારી speed કદાચ વધારે હશે type કરવામાં because you are current generation students using mobile a lot, but still if you unmute and speak here, then it will be very much cleaner for everyone. Well, Hers is saying binary digit 0 and 1 where all the computer memory works on bits, where all the bits goes to CPU and gives input. Yes, but from where CPU gets that input? Look, Jim, is there any out of Gujarat student here, or everyone is Gujarati? Sometimes it's more required to have discussion in the mother language, then you might get it clearly and quickly. Any student out of Gujarat here? Yeah, okay, then look, એ વિડીયોમાં તમે ધ્યાનથી જોયું હોય તો સૌથી પહેલો પોઈન્ટ એ આવ્યો કે પ્રોસેસરને ઝીરોઝ એન્ડ વન્સની સિક્વન્સ મળે, રાઈટ? Zeros and ones ni sequence, because computer processor can understand binary data zeros and ones, so zeros and ones ni sequence આવે. Now if you closely look at the configuration of your processor, generally આપણે પ્રોસેસરને કઈ રીતે જજ કરીએ એની સ્પીડ ઉપરથી. So કોઈ પણ પ્રોસેસર હોય તો તમે જોશો 1.5 GHz પ્રોસેસર, 2.1 GHz પ્રોસેસર, અથવા તો અલગ અલગ કોર્સ હોય, high performance course 2.1 GHz, low performance course 1.5 GHz, and so on. Well, that's gigahertz is actually the speed of that processor. આટલી સ્પીડમાં એ કામ કરે છે. Fine. Now પ્રોસેસર જો એટલી સ્પીડમાં કામ કરતું હોય તો એને ઇનપુટ પણ એટલી સ્પીડમાં જોઈશે. આઈ એમ રેડી ટુ ડુ માય ટાસ્ક, પણ મને ઇનપુટ તો આપો. પ્રોસેસર એવું કહેશે, રાઈટ? મને ઇનપુટ મળે તો હું આગળ કામ કરું ને. Now પ્રોસેસરને ઇનપુટ ક્યાંથી મળશે? Now that's gonna be either your input when you type something on a keyboard or કંઈક આપો, અથવા તો હાર્ડ ડિસ્કમાંથી કે જે સ્ટોરેજ મેમરી આપણી છે ત્યાંથી લઈ આવે. Fine, that's where it gets input. Now જો આપણે ટાઈપ કરીએ છીએ તો જ્યારે ટાઈપ કરશું ત્યારે જ એને ઇનપુટ મળશે, and whatever we type in a keyboard or whenever we give some input, it needs to be converted to binary data first, and then it needs to be fed to the processor. હવે માનો કે આપણે કંઈક એવું કરીએ, માનો કે આપણી હાર્ડ ડિસ્કમાં એક મૂવી પડ્યું છે, વી ડબલ ક્લિક ઇટ એન્ડ વી વોન્ટ ટુ સી દેટ મૂવી. લેટ્સ કન્સિડર ધીસ સિનારિયો. What happens in when we do this process, right? આપણે તો સિમ્પલી ડબલ ક્લિક કર્યું એ મૂવી ફાઇલ ઉપર, અને શું થાય છે કે એક મૂવીનો જે કાંઈ પણ સોફ્ટવેર તમે નાખેલો હશે અને ડિફોલ્ટ લિંકિંગ હશે, એ સોફ્ટવેર ખુલશે અને સોફ્ટવેરની અંદર એ મૂવી લોડ થશે અને પ્લે થશે. બિહાઇન્ડ ધ સ્ક્રીન વોટ હેપન્સ ઇઝ, સૌથી પહેલાં એ સોફ્ટવેર તમે ઇન્સ્ટોલ કર્યો છે, એટલે ક્યાં ઇન્સ્ટોલ થાય? તમારી હાર્ડ ડિસ્કમાં જ ઇન્સ્ટોલ થયો હશે. તો પહેલાં એ સોફ્ટવેર લોડ થશે અને એ સોફ્ટવેર રન થશે, એક્ઝિક્યુટ થશે. એટલે તમારું પ્રોસેસર જે છે એ સોફ્ટવેરનો કોડ રન કરશે. સોફ્ટવેર ઇઝ નથિંગ બટ અ પ્રોગ્રામ. ફાઇન. તો એ પ્રોગ્રામ રન થયો. હવે એ પ્રોગ્રામ રન થયો એટલે પ્રોગ્રામને ખબર પડી કે મારે આ ફાઇલ, આ વિડીયોવાળી ફાઇલ બતાવવાની છે. તો એ પ્રોગ્રામ, એ સોફ્ટવેર શું કરશે? એ ફાઇલ રીડ કરવા જશે હાર્ડ ડિસ્કમાં, અને એ ફાઇલ રીડ થશે હાર્ડ ડિસ્કમાંથી. એ રીડ થાય એટલે એ પ્રોસેસરમાં આવે, બિકોઝ પ્રોસેસર ઇઝ ધ થિંગ વેર એવરીથિંગ ગેટ્સ એક્ઝિક્યુટેડ. તમારો સોફ્ટવેર, તમારી ફાઇલ રીડ થાય, એને ઇન્ટરપ્રિટ થાય, એને ડિસ્પ્લે થાય, બધું જ પ્રોસેસરમાં થાય છે. નાઉ પ્રોસેસરની સ્પીડ બહુ જ હાઈ છે, બટ તમારે હાર્ડ ડિસ્કની સ્પીડ લો છે, બિકોઝ હાર્ડ ડિસ્ક ઇઝ અ મિકેનિકલ ડિવાઇસ. એની અંદર પ્લેટ હોય જે ગોલ ગોલ ફરે, એના ઉપર હેડ હોય જે ટુ એન્ડ ફ્રો મૂવમેન્ટ થાય, આગળ પાછળ મૂવમેન્ટ થાય, અને રીડ કરે, અને રીડ કરીને બસ થ્રુ, રાઈટ, ડેટા બસ જે છે તમારા મધરબોર્ડ ઉપર, એના થ્રુ એ 1-0ની સિક્વન્સ તમારા પ્રોસેસર સુધી પહોંચે, ત્યારે પ્રોસેસર એને પ્રોસેસ કરી શકે. Now there is a huge gap in between the speed of hard disk and the processor, right? જે સ્પીડમાં પ્રોસેસર કામ કરે છે એ સ્પીડમાં તમારી હાર્ડ ડિસ્ક કામ નથી કરી શકતી. That's the problem. તો પછી પ્રોસેસરનો ટાઈમ વેસ્ટ થશે, રાઈટ? સો બિકોઝ ઓફ દેટ રીઝન આપણે શું કરીએ કે ભાઈ ટુ ફિલ ધીસ ગેપ, હાર્ડ ડિસ્ક અને પ્રોસેસરની વચ્ચે આપણે એક રેમ લઈ આવ્યા, મેમરી, રેન્ડમ એક્સેસ મેમરી, રેમ. હાર્ડ ડિસ્કમાંથી ડેટા રીડ થાય અને રેમમાં સેવ થાય. તો પ્રોસેસર હવે કોની સાથે કમ્યુનિકેટ કરશે? રેમ સાથે કમ્યુનિકેટ કરશે ડેટા લેવા માટે. Now RAM is not a mechanical device, it's an electronic device. તો એની સ્પીડ વધારે હોય કમ્પેરેટિવલી હાર્ડ ડિસ્ક કરતાં, રાઈટ? ઇલેક્ટ્રોમેગ્નેટિક ડિવાઇસ કરતાં ઓનલી ઇલેક્ટ્રોનિક ડિવાઇસની સ્પીડ વધારે હશે, કારણ કે ત્યાં ક્યાંય પ્લેટને ગોલ ગોલ ફરાવવાની કે હેડને મૂવ કરવાની જરૂર નહીં પડે. So using RAM, we kind of create a bridge in between hard disk and a processor. And it is RAM, random access memory, because at a time એક જ સોફ્ટવેર રન થતો હોય એવું નથી. મલ્ટિપલ સોફ્ટવેર્સ આર બીંગ રન ઇન યોર પ્રોસેસર. પ્રોસેસરને ક્યારેક વિડીયો ફાઇલ જોઈશે, તો ક્યારેક ટેક્સ્ટ ફાઇલ જોઈશે, તો ક્યારેક બીજી કોઈક વસ્તુ જોઈતી હશે. હવે એ બધી જ વસ્તુ પહેલે રેમમાં લોડ થાય, તો રેમમાં ગમે ત્યારે ગમે ત્યાંથી મને ડેટાની જરૂર પડે. So I need to access that RAM, I need to access that memory randomly. That's why it is RAM, random access memory. And it is purely electronic. અને ઇલેક્ટ્રોનિકમાં કોઈ મિકેનિકલ મૂવમેન્ટની જરૂર નથી, તો એની સ્પીડ થોડીક વધારે છે. Now still પ્રોસેસરની સ્પીડ અને રેમની સ્પીડ અલગ છે, right? Processor works in gigahertz, whereas if you look at the configuration of your RAM, તો એ સમથિંગ મેગાહર્ટ્ઝમાં હોય છે. રેમનું કન્ફિગરેશન તમે ચેક કરો તો. So still we do have a gap, or we have inconsistency between the speed of processor and RAM both. તો એમ કહીએ કે અરે યાર તો પ્રોસેસરને હજી વેઇટ કરવું પડશે થોડુંક. To fill this gap, we have cache memory inside processors. Okay, which is not a RAM, which is actually SDRAM. RAM is DRAM, dynamic random access memory, whereas cache are SDRAMs. Okay, cache memory. Now cache memory તમારા પ્રોસેસરની સાથે આવે. If you look at the configuration of your processor, L1 cache, L2 cache, L3 cache આ તમને જોવા મળશે. Right? So L1, L2, L3 મતલબ ત્યાં હજુ વધારે હાયરાર્કી ક્રિએટ કરી. હાર્ડ ડિસ્ક થી RAM થી cache memory ને cache memory થી processor. That's what the hierarchy we create. And a cache માં પણ multi-level L1, L2, L3 cache memories. So those cache memories are having much higher speed comparatively your simple RAM, which again creates a bridge between processor and a RAM, processor and a memory. And those cache memories are much faster compared to RAM. So હવે શું થશે કે પ્રોસેસર જે છે એ કેશમાંથી ડેટા રીડ કરશે. Now what happens is તમે એમ કહો છો કે મારે મૂવી જોવું છે તો મૂવીનો સર્ટેન પાર્ટ હાર્ડ ડિસ્કમાંથી રેમમાં આવશે. હવે રેમમાં જેટલો પાર્ટ આવ્યો છે એમાંથી સર્ટેન પાર્ટ રેમમાંથી પહેલા કેશ મેમરીમાં જશે અને કેશ મેમરીમાંથી એ જે મૂવીનો પાર્ટ છે એ પ્રોસેસરમાં જશે તો પ્રોસેસર એને પ્રોસેસ કરશે. Now when processor process that data and generates the output, તો એ આઉટપુટ તમારી સ્ક્રીન ઉપર એઝ અ મૂવી ફોર્મેટમાં દેખાશે. Fine? Now when you play that movie, તો પ્લે થાય છે એટલે એને તો તમે સ્પીડ અપ નહીં કરો. તો જેટલો પાર્ટ કેશમાં છે એટલો પ્લે થાય. Now પ્રોસેસરને જ્યારે નેક્સ્ટ પાર્ટની જરૂર પડશે તો એ નેક્સ્ટ પાર્ટ રેમમાંથી કેશમાં લઈ આવશે અને પ્લે કરશે. સો કન્ટિન્યુઅસલી આ ચાલશે. રેમમાંથી પાર્ટ કેશમાં લઈ આવો, કેશમાંથી પ્રોસેસરમાં આવે અને પ્લે થાય. જ્યારે રેમની અંદર જેટલો પાર્ટ લોડ કર્યો એ કમ્પ્લીટ થઈ જશે તો રેમમાં શું થશે, હાર્ડ ડિસ્કમાંથી બાકીનો મૂવીનો પાર્ટ રેમમાં આવશે, રેમમાંથી કેશમાં જશે ને કેશમાંથી પ્રોસેસ થશે પ્રોસેસરની અંદર. That's how that process goes. Okay, so that's what happens. So હાર્ડ ડિસ્ક કરતા રેમની સ્પીડ વધારે છે, રેમ કરતા કેશની સ્પીડ વધારે છે અને કેશ કરતા પ્રોસેસરની સ્પીડ વધારે છે. And to match this speed we have created this hierarchy. પ્રોસેસરને જલ્દી ડેટા મળી શકે એટલા માટે આપણે આ ડિફરન્ટ લેવલ્સ ઓફ હાયરાર્કી ક્રિએટ કરી. And those memories are created in a different manners. SDRAM, DRAM, and electromagnetic device to store that data. આ વિડીયોમાં આ બધું એક્સપ્લેન કર્યું હતું. Then hard disks are much slower because they need to have a mechanical process, right? Nowadays we do have SSD, solid state drives, SSDs. Now solid state drives, SSDs are purely electronic devices. And so they have much higher speed compared to hard disk. Now we will see how hard disk works and how SSD work also. But SSD શું કામ સ્પીડમાં કામ કરે છે? Because પહેલો પોઈન્ટ એ ઇલેક્ટ્રોનિક ડિવાઇસ છે, એને કોઈ મિકેનિકલ વર્કની જરૂર નથી. બીજો પોઈન્ટ, અલગ અલગ રીતે એની અંદર ડેટા સ્ટોર થઈ શકે. NVMe SSDs or M2 SATA SSDs and so, right? So we will see that part also. That અલગ રીતે જો SSD બની હોય તો એની સ્પીડ પણ અલગ હોય. Well, so that's what a basic introduction part in this video you have gone through. So if any more questions you have, then please ask. Otherwise, we'll go for the next video. Any more queries or questions at this place? Okay, well, if not, then let me post another link for second video. Oh, sorry, wait. Some of you have asked, but I couldn't see that thing. Well, let me go through that thing. Binary digit 0 and 1 computer memory, and bits were all the bits goes. Yeah, that was the discussion part. So a little confused regarding working of all three types of storage. Yeah, so Vyom, are you clear now? Different three types of storages. Computer of short-term memory, immediate task. Well, short-term memory is something, the RAM and cache we are talking about. It is short-term memory because when we cut off the current, it is going to be erased. Long-term memory is the hard disk and SSDs and other secondary storage devices that we use. That's the long-term memory. Yeah, in video it shows that dynamic RAM is commonly used, made up of transistors and capacitors. Yes, well, short-term memories are mostly created using transistors and capacitors. Transistor is something which stores the current, right? So it's either 0 or 1. No current, then 0 stores the current inside it, then 1. But transistors are very short in occupying that current. The leakage is always there, and in that case, if we want to maintain that current inside that transistor, then we need some capacitor. So that's why, and that's how it is being created, dynamic memories, right, Harsh? Nishar Alam. Okay, we have one student out of Gujarat, so now I need to speak in English only, English or Hindi. Cache memory made from static RAM, made up of 6 interlocked transistors. Yes, cache memory does not use capacitor because it need not to retain that current for a longer period of time, and that's why it does not need capacitors there. It only consists of transistors. Octane memory, Manav is asking. Well, that's the totally different field. You can search about it. I'm not going to cover that part right now. Viraj is asking me to repeat the entire process one more time. Okay. And Hers is having one question. At last, it shows that CPU heated, then data lost. Data loss is possible. How? Yeah. One, look, CPU, your processing unit is nothing but transistors. Transistors, capacitors, and an electronic device. When current passes through some let's say electronic component, it generates the heat, right? And that's why when we let's say our desktop PCs requires that fan to cool our processor. Even laptops do require that fan inside it to drop down the temperature of that processor. And nowadays, new technologies are coming, and small, even nanometer scale, we are developing processors so that they generate less heat. And that's why in our phone, we do not have any kind of fan, and new laptops are being um, generated without fan also because of the current technology, but still there is some kind of a heat generated when our processor does some task. Now, if that heat is generated, then that heat is going to work as a resistance, and the capacity of storing your current inside those transistors may degrade, and that's how you are going to lose your data inside that RAM part. That's the main reason behind that. Okay, so am I clear, Hers? Yeah. Vyom is asking, smartphones, we have even 5 nanometer processors, but why is it difficult for laptop processors? Also, what to know of the course? Well, Vyom, if you look at the Apple silicon processors nowadays, then they are generating those nanometer processors now. M1 chip is maybe 5 or 8 nanometer process based, right? So that's the limitation of designs that Intel or AMD are following. But nowadays, once Apple has come up with M1 chip, even Intel Evo processors, 11th generation processors are matching up that thing, and AMD is coming with a new generation of their processors, and then that thing will happen. But the main reason behind that is a designing process and a development process is the main hurdle behind that. Design and develop those processors at that scale, the need of the current world is not feasible right now, and that's the limitation. But slowly that production process will increase and we'll have those things available. More bits is sent to CPU where it can resist more amount of bits when decided. Well, look, I don't understand clearly what you are saying, Hirsch. If more bits are sent to CPU where it can't resist, I'm not clear. Please, if you elaborate more on your query. Why AMD and Intel need to launch new generation of processors every year? Look, electronic field is continuously evolving field right now. You're talking about every year. Well, if you look at mobile processors, every 6 months you have a new processor. Actually not needed, but these giants are actually creating that hype that something new has introduced, and you need to buy it. And there, I believe, this is what I believe, their business will go on and on. Otherwise, you can have your phone 3 or 5 years old and still you are comfortable with that. You will be comfortable with your laptop for 6 or 8 years also, until and unless you have that type of work which requires new processor. Fine. So no need to go for a new hardware every year, but they are evolving, they are giving the new technology, and they need their business to be expanded. Vyom is asking, can we insert more than one processor in a PC for faster performance? Look, if you recall the basic block diagram, then in your processor you have ALU, MU, and CU. CU, control unit, is responsible to control everything. So CU, control unit, is a part of processor. Correct? Now, if you do have two different processors, then you'll be having two different control units. अब ये दो कंट्रोल यूनिट जो है वो झगड़ा करेंगे एक दोनों के साथ, दोनों एक साथ मतलब एक दूसरे के साथ झगड़ा करेंगे. That's why we have a problem. We can have multi cores inside a single CPU. Multiple cores. If we want to increase our process capability, we can have multiple cores that can run process simultaneously. But control unit will be single one there. Now, if we want to have multiple processors, then we need to have one more hierarchical level which will control those two processors, right? एक और लेवल जनरेट करना पड़ेगा जो वो दोनों प्रोसेसर को कंट्रोल कर पाए. Then it is possible. Well, earlier I think Viraj was asking me to repeat the entire process. Let me repeat the process that we have discussed right now. We want to play a movie. Then what happens is, first of all, our movie player will be executed because movie player is the software and that's need to be executed in processor. अब वो सॉफ्टवेयर जो है आपने जब इंस्टॉल किया आपके हार्ड डिस्क में है या समवेयर सेकेंडरी मेमोरी में है. प्रोसेसर रन्स वेरी मच फास्टर कंपेयर्ड टू योर हार्ड डिस्क. तो जो स्पीड में आप हार्ड डिस्क को रीड करते हो उससे काफी ज्यादा स्पीड है प्रोसेसर की. अगर आप वो मैच नहीं कर पाओगे तो प्रोसेसर का टाइम वेस्ट होगा. नाउ to fill this gap, we have RAM in between. So hard disk जो था वो mechanical device था, electromagnetic device था, whereas RAM is a electronic device. So electronic device जो है उसकी speed comparatively hard disk से ज़्यादा है. So we fill that gap. Somehow we reduce that speed. अब होगा क्या? From your hard disk, a bunch of code, a bunch of part is being read and stored inside RAM. अब processor जो है वो RAM के साथ communicate करेगा because RAM is having higher speed. Now still we have a gap in between the speed of processor and RAM, so we fill that gap using cache memory. So आप अपना processor अगर configuration check करो तो आपके पास L1 cache, L2 cache, L3 cache and so on होगा. So those cache memories are having much higher speed than the RAM because RAM is built using transistors and capacitors, whereas cache memories do have only transistors. Now why? Because RAM के अंदर जो हम data store करेंगे, maybe it will take some longer time. But cache memory के अंदर जो हम data store करते हैं, it is only for processor to read and then wipe. Okay, so that's why it is not needed capacitors there. Well, so that's how everything works. Hard disk की space capacity सबसे ज़्यादा होगी because it is a secondary device, memory storage. RAM की comparatively कम होगी. Cache memory की size RAM से भी कम होगी. And when you have different levels of cache memories, L1, L2 cache, L1 cache, L2 cache, L3 cache, तो वो 3 level में भी आपको अलग-अलग size देखने को मिल सकती है. So when we go towards processor, memory size will decrease because we need not to have that much amount of memory. We need not to store that amount of data because processor can process that data quickly. अगर processor जल्दी उसे process कर देता है तो हमें बड़े amount की memory data जो है वो store करने की ज़रूरत नहीं पड़ेगी. So जैसे ही आप processor side जाते हो, size memory की size जो है वो कम होती जाती है. ठीक है? Well, so that's all about the entire process. Now, what I'll suggest is let me post that second video link one more time. Go through this second video, have a look at how hard disks work. Now, this second video is all about hard disk. Okay? Just keep this video on screen, but you need to go for your screen, your YouTube player. It might be the case that you do not hear the voice here of this video. Or else let me go for speaker and mic. Yeah, sorry, I was muted. Yeah, but I was explaining that video how everything happens. So we have a number of disks, and all the disks will have the heads, which is going to read and write. Viraj is saying video ma language bow high English hoti. Well, need to understand, pause and play those videos to digest all the statements and try to understand those things. I know that many of you will be facing problem in English for first year. But if you are not going to tackle that problem right now, then you are going to have that problem throughout your engineering journey. What we should do is we should target that problem and try to solve that problem in first year itself, so that from the second year you'll have less problems with English, and maybe in the third year you'll be very fluent in English reading and writing. Reading, writing, listening, and speaking, everything, right? Well, so again, going through that video, we have number of plates, disks inside the hard disk. Every disk will have head to read and write data. Now, inside that disk, we are going to store our data, but not in the form that we understand. Our data will be in the form of zeros and ones. That's what computer understands, but not exactly 0 and 1. In your hard disk, that data is going to be stored in the magnetic field. Now, when we talk about magnetic field, we have two directions, North Pole, South Pole, and so north and south kind of a direction. So inside that magnetic plate, magnetic disk, we are going to store our data in terms of directions, left side or right side. This is just an example, but magnetic field. Now, how do we do that? So that head on top of that disk has magnetic field generator, right? So it will generate that magnetic field higher enough to change the direction of your data inside your disk, hard disk plate. Okay, so that's how your data will be stored, and that's how you can read and write your data on the hard disk. Okay, fine. So Vyom is asking, cache is supposed to make the device faster than why when the device hangs, we clear cache and how system is working good again. Look, these two has two different scenarios actually. Definitely cache memories are there to fill the gap between RAM and a processor, okay? And when we say computer is stopped working and we clear the cache memory or something, and it gets faster, that's not the actual cache memory of your processor. It is the cache memory of your operating system, which are the pages which are there in the RAM. Okay, so these two scenarios are different. Okay, any more queries from this video, hard disk related video? Yeah, Samarth is asking, what if the magnetic field generator stops working, or so some fluctuations with how it can be resolved? Yeah, look, magnetic field generator is nothing but the head that we talk about. The head is responsible to read and write data on the disk. Now, if it is malfunctioning, then we can say that our hard disk is not working properly. From the electronic signal, your head is going to change that electronic signal to magnetic signal, magnetic waves. And using those magnetic waves, your data will be written onto the disk or read from the disk. If it is not working properly, then we say, हम ये बोलेंगे कि हमारी hard disk खराब हो गई. Now, if it is the only problem with your head, okay, then it might be resolved. But most of the time, what we do is we never open hard disk. Otherwise, your data is going to be erased, right? So that's the problem. You cannot open your hard disk simply in and anywhere, and it's not going to work properly. It has some problems and all. Well, but with some controlled situations, you can repair your hard disk if possible. But instead of going for that way, we have another replacement way is easier. Yeah. Any more queries? Well, how the where I stop this video, if you complete this video, then they are explaining how uh, they create this kind of structure in a very small area. So they have talked about technologies, they have talked about mathematical algorithms to shrink down our data. They have talked about nanofilm and thin film technology to work around. So that's a totally design field so that we can decrease the size. Horse is asking, sir, is it possible that increasing density of material and shrinking of grains happen then grain gets overlapped and the output will be unpredictable? Well, I, frankly speaking, I haven't got in this thought, so maybe or may not be, I don't know, but that's purely the design perspective. What we can achieve and up to what extent we can achieve that thing. Well, Vyom is asking, can we make a surface of hard disk zigzag or irregular to increase the surface area? Well, if you do that thing, then first and foremost question comes to my mind is, if you do that thing, then you will not be able to have evenly distributed magnetic field on your surface. If that surface is zigzag and your head is generating magnetic field, then the effect of that magnetic field will be different in the different surface area. Then you will end up with a different problem, reading and writing problem. You increase your surface, but you'll have another problem, reading and writing. Yeah, okay. Yeah, so that was something related to um, hard disk. Let's have one more video on hard disk. Let me paste that link here, and let me confirm that I'm having that video on the screen with voice. Yeah, so you can hear this thing now, probably. So till this time, this video was explaining how everything works inside the hard disk. We have number of plates, disks. Every disk will have a head on both the sides. That head is nothing but magnetic field, means transducer, which will read or write that magnetic field in terms of 0 and 1 data directions. Inside this part, you have a magnet and the coil which generates those magnetic fields. And as they have said, on this disk, we have a number of tracks, and 300,000 tracks, they have been achieved inside the size of 1 inch, right? So that was the construction of your hard disk. Now it explains how data is being recorded on this. Yeah, so when we try to read or write something in a hard disk, those heads will move to and fro. So it'll go up to the sector, the track we were talking about inside that disk. Okay, your head will move up to that track, and it will then read that data magnetically from that track. And then that data is being transmitted electrically from the channel bus, goes to the processor interprets everything, data, and then it is going to give us the output. In the output section, maybe it's the screen. Well, that's how this hard disk works. Yeah. So hopefully that is this video creates more, gives you more clarity on how hard disk work. Now, many of you were talking about SSDs, and let's have one video on SSD. What is SSD and how it works? So let me post that link and also open that link here on the screen. So what it says, if you look at one unit part, right, then it can store your data in bits, 3-bit sequence, 000 to 111, and they have that data using electrons stored inside that. And once it has been stored there, it can be there for years and years. Now if we want to remove those, then forcefully we will remove those electrons from those places, and it will erase that memory part. Yeah, hers is saying video and audio is lagging. That's why I've posted video link also. So if you want to go through that, you can also go through that link and have a look at that video once. Well, so what it follows is it follows a 3D structure where you have rows, columns, and multiple layers, right? Number of rows, number of columns will create one sheet, and those kind of multiple sheets of that kind you have here, which means just imagine what amount of data you can store here. That's why SSDs are much higher in the capacity to store the data. Yeah, so when you say that you want to have read or write that data, you have control gets and bitline selectors, right? You have control get selectors and bitline selectors. So control get selectors are going to select the columns. Bitline selectors are going to select the rows. Rows and columns are selected. Then you'll have that place from where you can read that data. Now, Samarth is asking, how does the format function works? How does the data gets erased from the hard disk? Well, it's kind of forcefully changing the type of how we store that data. If you are talking about hard disk, okay, if you are talking about hard disk, then it is going to make every bit in a single line, single aligned. Let's say everything will be pointing to one direction. That's the format. Bring it to the initial state, right? If you are talking about maybe this SSDs, then remove every electrons from that charge flap, make it empty, and so on, right? So that's how it works. Now, not only that thing, when you do this thing, this is a permanent formatting, complete formatting. But if you talk about simple, quick format, in our operating system, then it is not going to remove your data from the hard disk or SSD actually. It is just going to remove the mapping, right? Mapping is nothing but index. Like in a book, you have your index. So whenever I want to to retrieve something, I'm going to first index, I'll find the address, I'll find the page number, and then I'll jump to that page number and read that part. Similarly, operating system runs. Operating system always builds some kind of a map, kind of an index, from where it can have the address of the actual data. Then jump to that address and read that data. So quick format will simply remove this index, remove this mapping. So we don't know where my data is, so it is removed. Full format, when you go, then it is actually going to remove your data from the actual place. That's what the difference between formatting process, okay? Well, so that's what the SSDs are and how they work. Now, what we'll do is now, let me stop this recording. It's a very lengthy recording here. I'm going to stop this recording and we'll stop at this place, but now I give you your task. You explore by yourself, have some videos on SSDs, RAM, ROM, and hard disk. Try to understand those things. And wherever you feel any difficulty, you can ask me. We'll go for the discussion and try to solve those queries here, right? But we will be here till the end of this lab. Okay. Now, before I stop this recording, let me have your attendances. So everyone will post their enrollment number in the chat box now. When you post your number, your name is going to be there by default. Along with that, I want your enrollment number here. So post your enrollment number in the chat box and your attendance will be recorded. Doesn't matter GTU or MU, just post your enrollment number. I'll find it out from your enrollment number whether it is GTU or MU. Everyone, just post your number, enrollment number in the chat box. I'm going to filter it out. Just post your enrollment number only, okay? Because your name is already there. No need to post your name. It is already there. Just post your enrollment number. Once you are done with that, you may switch to other videos, have a look at those videos and try to understand everything. Done, everyone? No hurry, you are not about to leave this meeting. Have a look at the video. Let's discuss some videos. I'm going to stop this recording for just to have a less amount of size of this recording. Okay? So let me stop this recording now. And we all are here till the end of this session. You can watch some videos and then discuss here in the chat box, or you can unmute yourself and discuss whatever video you have seen with other guys. Sharing will increase your understanding and knowledge base always. Yeah? So go for it now.